Let's start with our next lecture on NEET PYQ, and this is our third lecture on work power energy. If you have not watched the previous two, the link is in the description. Let's start with our first question. The question says force F on a particle moving in a straight line varies with the distance d as shown in the figure. Fine. The work done on the particle during its displacement for 12 meters. So 12 meter is up till here. We have to find the area of this FD curve. Okay, so if you are given with a graph between force and distance, we can find the area between the curve, okay, going from 3 to 12. This will be our work done, right? So how do you find the area? The first area will be our here, this area of trapezium from here, or area of you can directly find the area of trapezium to find the area, right? So what will be our area of trapezium? It will be half sum of parallel sides a plus b into the height between them, right? Where a here is this distance. So this distance we can see here, it is 3 to 7, which is 4. So half 4 plus the second parallel side 3 to 12, this is how much? 9. And the vertical height is 2, so into 2. Let's cancel out this 2 with 2, so we left with 9 plus 4 13 joules. So correct answer is 13 joules, option D. I hope this is clear, right? Let's move to our next question. Our next question here is this one. Great. Our next question says a body of mass 3 kg, let me write here m equals to 3 kg, fine, is under a constant force which causes a displacement s in meters in it, given by the relation s equals to 1 by 3 t square, right? 1 by 3 t square, it's a function, displacement is a function of time. Great. Where t is in second, work done by the force in the 2 seconds. So time here is 2 seconds. We have to find the force in 2 seconds. Work done. We have to find the work done by this force in 2 seconds, right? So we know that work done is nothing but force into displacement, and force is nothing but mass times acceleration into displacement, right? So first of all, what we will do here is we will figure out our acceleration, right? So let's differentiate the displacement function. So velocity will be equals to ds by dt. On differentiating it, you will get 2 by 3t, correct? This is our velocity. And what about acceleration? So acceleration will be the second derivative of distance or displacement. dv by dt will be equals to 2 by 3, correct? So acceleration is 2 by 3. Let's substitute here values. Mass is 3 kg. Acceleration is found to be 2 by 3. And the displacement the particle has done in first 2 seconds. So let's substitute here 2 in this displacement function, right? So this will be equals to 1 by 3 into time is 2. So 2 square. Let me repeat again. Mass as per the problem is 3 kg. Acceleration as per the problem we got as 2 by 3. And the displacement here will be 1 by 3 t square. 1 by 3 t square, and time we have placed as 2 seconds. Clear? So this will give us 2 cancels with 3, will cancel with 3, and we left with here 2 into 2 2s are 4 by 3. Correct? So that will be 8 by 3 joules. That's our correct answer. So correct answer here is 8 by 3 joules. Option D is correct. I hope this is clear, right? Let's see the next one. Great. Our next question says a force F acting on an object varies with the distance x as shown in the figure. The force is in Newton and x is in meters. The work done by this force in moving the object from x equal to 0 to x equal to 6. Clear? So while going from 0 to 6, this whole area will be included. So there are two ways. Either you solve it as a square or a rectangle plus a triangle. You can solve it like this, or you can directly use the area of trapezium as we have done in the previous problem. And what's the area of trapezium? In case if you don't know, it's half sum of parallel sides into height. Now what is the first parallel side? This one. So what is this length? 3. So this will be half into 3 plus. What is the second parallel side? This one is the second parallel side. So 0 to this is 6. Great. And what is our height? So this height is 3. Fine. So this will give us half into 3 plus 6, 9 into 3. Clear? So 9 3s are 27 upon 2, and 27 upon 2, 2 1s are 2, 2 3s are 6, 13.5 joules. Is there such option? Yes, option B is correct. Understood? So area under the force and the displacement graph will give you always what? The work done. Let's see the next question. Great. Our next question says a force acts on a 3 gram particle. So mass is here is 3 grams. So let me write here 3 into 10 to the power minus 3. Okay, fine. Particle in such a way that the position of the particle as a function of time is given by, so x is nothing but 3t minus 4t square plus t cube. Great. Where x is in meters and t is in second. The work done during the first 4 seconds. So first 4 seconds means time t equal to 0 to time t equals to 4 seconds, we have to find the work done, right? So there is another way. I am using the second method to solve the work done. What is the work done? The amount of work done on any system changes its kinetic energy, right? So that's work energy theorem. So we will make use of that. So first we will find the velocity at t equal to 0, then we will find velocity at t equal to 4 seconds, then find the difference of kinetic energies, right? So how do you find velocity? By differentiating such a function. So v will be equals to dx by dt. By now I hope you are habitual with the differentiation. What is the differentiation of 3t? It's 3, sir. And what's the differentiation of this, sir? Minus 8t. And what's the derivative of t cube, sir? 3t square. I hope this is clear, right? So this is our velocity function. And if this is a velocity function, what's the velocity at t equal to 0? So velocity at t equal to 0 is nothing but 3 meter per second, right? Putting t as 0 here, it will be 3 meter per second. I hope this is clear. What's the velocity at 4 second? Let's solve it. So velocity at 4 second will be 3 minus 8 fours are 32 plus 4 fours are 16, 3s are 48. Correct? So now 48 minus 32, that's how much? 8 minus 4, 8 minus 2 is 6 and 16. Correct? Now plus or minus plus. So 16 plus 3, that is 19 meter per second. I hope this is clear. This is the velocity at 4 second, velocity at 0 second. Initial velocity, final velocity. Now what is our work done? Sir, work done is change in kinetic energy. Work energy theorem says, so half mv square minus half mu square. And let's substitute these values. So half m taking common. What's the m? Sir, m is 3 into 10 to the power minus 3. What's the velocity square here? 19. So 19 square minus u square, which is nearly 3 square. Okay, great. So this will be equals to 3 by 2 into 10 to the power minus 3. Let's remove this 10 to the power minus 3 because anyways the final answers are in millijoules. So this will be considered as millijoules, 10 to the power minus 3. So 3 by 2 into 19 square. Let's figure out what is the square of 19. So 19 into 19, 9 9s are 81, 8, 9 8 17, 9 1, okay. 9 and 1, this will be 1, 9 6 and 361. Clear? I hope this is clear. Let me redo it. 19 into 19, that's 9 9s are 81, 9 8 17, and this will be 1 9 1, okay, 1 and 6 and 3. So 361 is the 19 square, right? Now 361 minus 9. So that will be equals to 1.5 into 11 minus 9, which is 2. Oh, it's ending with 2. So let me just keep it as 3 by 2. 11 minus 9 is 2, 5, and this will be equals to 3, 352. Correct? Let's multiply here. So 2 ones are 2, and this will give you 15, 2 7s are 14, 176. Correct? Okay. I cancel 2 with 352. So this will give us how much? 3 6 are 18. 3 7s are 21 and 22, 528, approximately 530 joules. Clear it is? So this is millijoules. So 530 millijoules at approximately. I hope you are clear with the concept. Let's move to the next question. Great. Our next question says a position dependent force. So F is dependent on position. Be very careful. This is not time dependent force. It's position dependent force. Acts on a small body of mass 2 kg. So M is 2 kg here. Displaces it from x equal to 0 to x equals to 5 meter. I hope this is clear. The work done in joules will be how much? Clear it is? Now we know if there is a function of force depending on the displacement, then this is integration of f dot dx. We already know this, right? Very fundamental or basic formula. So f will be here taken as 7 minus 2x plus 3x square, and our integration will go from 0 to 5. So this will be 0 to 5 dx. I hope this is clear. Great. Now let's integrate it, taking 7 outside. What is the integration here? Sir, it will give you x because there is nothing. So 0 to 5 minus 2 taking out. This will be x square by 2, 0 to 5. 3 here outside, x cube by 3. I hope you are familiar with the integration. Clear? Then only you will understand such things. Okay. So here putting the upper limit minus lower limit, it will be 5 minus 0. So I'll not put the 0 again and again. I'll just keep it 5. Minus 2 and 2 cancels. You left with 25 minus 0. And 3 and 3 cancelled. You left with 125. Correct. So this will be 7 5s are 35. minus 25 plus 125, correct? Now what is 35 minus 25? Sir, it's obvious, it's 10, and 10 plus 125, it's 135. Clear? So is there such an option? Yes, in joules it's 135 joules. I hope this is clear. 35 minus 25, 10, 10 plus 125 is 135. Great. Let's see the next one. Okay, now we are given with the potential energy as a function of position. Clear? So it's related. The topic is from equilibrium, right? If you remember, let's come back to the question. All these are PYQs. So our question says the potential energy of a particle in a force field is, our force field here, potential energy is given by A by R square minus B by R. Great. Okay. Where A and B are positive constants and R is the distance of the particle from the center of the field. Fine. For stable equilibrium, be very careful. For stable equilibrium, the first derivative will be 0. Okay. For stable equilibrium, the first derivative will be 0. The distance of the particle will be how much? Let me again repeat. I will use the concept that for stable equilibrium, the first derivative will be 0. So let me just find it as du by dr. Okay. Why it is 0? We know that F equals to minus du by dr. Okay. And for stable equilibrium, there is no force acting on the particle. So here du by dr will be equal to 0. Clear it is? So let's differentiate it. Now derivative of this, let me make it simple for you. So this will be A r to the power minus 2, because r to the power 2 will go up and it will make it r to the power minus 2, minus, be very careful with the signs, r to the power minus 1. Clear? Here it is equal to 0. Now there is a shortcut also, but I will not give you a shortcut, okay? Because here better is to understand the concept, okay? Only in stable equilibrium it is equal to 0. So people here in this particular case, they forget about these things, that we are talking about stable equilibrium. So now here it will be A r to the power minus 2 minus 2 r to the power minus 3. I hope this is clear. The power comes in front and the power decreases by 1. Okay, great. Here again the power comes in front and power decreases by 1. So when you decrease minus 1, it becomes minus 2. Beautiful. Let's take this whole thing on the other side, or let's take this off, because this is negative. Let's take this on the other side. So minus 2 goes that side, it becomes plus 2a and r to the power minus 3, r to the power minus 3. What you left with? Minus minus plus here. So this will be b r to the power minus 2. I hope this is clear. Okay. Now let's take this r to the power minus 3 that side. So r to the power minus 2 upon r to the power minus 3, that will be equals to 2a by b. And when you take it on the top, it will be r will be equals to 2a by b. I hope this is clear. Okay. So r equals to 2a by b, which is option B. Clear it is? Let's see the next one. Okay. The theoretical one, the potential energy of a system increases if the work is done by the system against a conservative force. That's the correct answer. The potential energy of a system increases if the work is done by a conservative force, okay, by the system against the conservative force, not by the conservative force. Okay. Let's see the next one. Okay. Similar to the previous problem, just now we did, let's do it. Okay, the potential energy between two atoms in a molecule is given by U equals A upon x to the power 12. In case you are not clear with the previous question, just look here. Okay, where A and B are positive constants and x is the distance between the atoms. The atom is in stable equilibrium. Let me recall the concept. Stable equilibrium means force being 0, right? So if the force is 0 here, let's see. So du by dr will be equals to 0. Okay. So what about r? R is a position vector. Here this position vector is x, because the potential energy is a function of x and not the r. Clear? So du by dx will be equals to 0 for stable equilibrium. That's the condition. So let's now differentiate it. Before we differentiate, let me express this potential energy u as a x to the power minus 12 minus b x to the power minus 6. There is a shortcut. Again, I am repeating. Better you differentiate and solve it. Okay, that will avoid many mistakes. Okay, so here what we will do, we will differentiate it du by dx. So a is a constant, x to the power minus 12. Sir, minus 12 x to the power minus 13. The power comes in front and it decreases by 1. Minus b minus 6 x to the power minus 7. I hope this is clear. The power comes in front and it decreases by minus 1. Now let's solve the first part further. So this will give you du by dx, that will be equals to how much? Minus 12a, oh sorry, du by dx is nothing but 0, so it's 0 here, and minus 12 a x to the power minus 13. Be very careful with the signs. Minus minus plus 6b x to the power minus 7. I hope this is clear. Okay. Now let's take this negative part on this side. It will be 12 a x to the power minus 13, and this will be 6b x to the power minus 7. Let's take this that side. So 12a upon 6b, that will be equal to x to the power minus 7 by x to the power minus 13. Let's cancel out 2a by b, and that will be equals to minus 13 and goes up. It will be plus 13. Plus 13 and minus x to the power 6. So this will give you x is equals to 2a by b whole power 1 by 6. And that is our option A. I hope this is clear. Okay. So this is the condition for stable equilibrium. These are two problems from stable equilibrium. Let's see the next one. Okay. Our next question is very, very interesting, from vertical circular motion. So you have to focus on this particular problem very, very carefully. Clear? So I'll remove few space also once I'll figure out few important concept, and then I will solve it. Okay. So just focus on the board very carefully. Okay. Let's start with our discussion. It says a bob of heavy mass m. Okay, fine, is suspended by a light string of length L. Okay, this is length L. So obviously this length will also be L. Okay, fine. The bob is given a horizontal velocity V naught. This is our horizontal V naught. And this question, this problem came in last year 2025. Okay, V naught as shown in the figure. If the string gets slack at some point P, this is point P, making an angle theta from the horizontal, the ratio of the speed of V of the bob at this point. What is the ratio of the velocity? And let's call it as velocity V, okay, to its initial speed V naught. So basically in this problem what we have, this is our previous year problem, means to 2025 problem. We have to find the ratio of velocity of this particular bob at point V or point P and at initial point here. So we have to find the ratio of V and V naught. That's our condition, right? And question is saying that at point P the string is getting slacked, which means the tension in the string is 0 at that point. That is very important condition. The slack is at point P, which means tension is reducing to 0. We will put this condition within a minute, right? So what I'll do here is I'll call this, I'll make a perpendicular here, and I'll call it as M. Okay, let's call, no, M is already there, small m. So to avoid confusion, let's call it as PQ. Okay, let's find the value of PQ. Now obvious it is that PQ will be nothing but L sine theta. PQ is L sine theta. This is L, so PQ is L sine theta. So if PQ is this and this is OM, our, let's call it as height H. What is height H? From this initial point to point P, the height is H. And that height H is nothing but OM plus PQ. And what is OM? Sir, OM here is L, and PQ you have just now calculated. So L plus L sine theta. So L taking common, it will be 1 plus sine theta. That's our height. Sir, why you calculated the height? Because we will use law of conservation of energy. And law of conservation of energy, we will find the total energy of the bob at this point will be equal to the total energy at this point, right? So let's find the total energy. So total energy at this point will be how much? Half m v naught square. And since it is the initial point, our potential energy at that point will be 0. That will be equals to, because we are taking it as reference, and with respect to this we are finding the height, not from ground, right? So this height here will be h. Okay, when it reaches at point P, the potential energy will be m g h, correct, where h is that height, plus what will be the kinetic energy? Half m v square. I hope this is clear. Okay, half m v square. What is v? V is the velocity at that point. What is the initial velocity? V naught. Sir, what is question asking? The question is asking the ratio of the speed v and v naught. That we have to find, right? Okay, we'll find that within a minute. Let's multiply the whole equation with 2 and divide the whole equation with m. Again repeating, multiply the whole equation with 2 so that this 2 gets eliminated, and divide the whole equation with m. Okay, so when I multiply with 2 and divide with m, this half m will go. I left with v naught square here, equals to, divide by m and multiply with 2. So 2gh. Sir, what about H? Can we substitute it? Yes, of course. Substitute H as L 1 plus sine theta. Great. H is L 1 plus sine theta plus multiply with 2 and divide by m, you left with V square. Equation number 1. I hope this is clear. Okay, let me repeat it for you. Multiply with 2, cancel this 2, divide by m, remove this, you left with V naught square. Here multiply with 2, 2 divide by m, went G H, H I substituted this value here, and here the same thing, you got V square, right? This is our equation 1. Great. Let's apply now here our force. So here the bob will experience a force of mg downward in direction, correct? This weight is downward in direction. There is no tension. So mg sine theta will be here, and that is equalizing at this point what? Our centripetal force or centrifugal force, whatever you call it. So mg sine theta in this case will be equals to mv square by r. And what is r? Sir, L here. Let's cancel out m with m. And let's find Lg sine theta is equals to V square. Let me repeat again. M cancels with M. I took L on the other side. Now what is Lg? Here it is. Lg here is, let's take the sine theta on the other side. So Lg here is V square by sine theta. Equation number 2. Let's substitute this equation 2 in equation 1 and simplify to get our answer. So V naught square will be equals to 2gl. 2gl. gl is V square by sine theta into 1 plus sine theta plus V square. I hope this is clear. Let's take this V square and take it on the other side. So V naught square by V square, that will be equals to what you left with. So 2 sine theta 1 plus sine theta plus 1. Let's simplify it further and get our final result. Okay, V naught square by V square, that will be equals to 2 plus 2 sine theta, and cross multiplying the sine theta plus 1. So plus sine theta all divided by sine theta. Clear? So this will be V naught square by V square will be equals to 2 sine theta plus sine theta, 3 sine theta whole divided by sine theta. Clear? Okay. Let's see again which one, the ratio of speed V. So just opposite we have to find. Let's reciprocal and find the root. So V by V naught will be equals to under root. I have reciprocated it. So I have to reciprocate on the right hand side also. It will be sine theta upon 2 plus 3 sine theta. Let's see if there is some answer like this. So it will be equals to sine theta upon 2 plus 3 sine theta whole power half. Clear it is? That's option B. I hope this is clear. Let's see the next one. Our problem says an object falls from a height of 10 meter above the ground. So this is, let's say this is 10 meters. Okay, fine. After striking the ground, it loses 50%. It loses how much? 50% of its kinetic energy. What is the height up to which the object can rebound from the ground, right? That is our simple problem. Okay. So if it is falling from 10 meter, what is the velocity of impact? What's the velocity with which it hits the ground? Sir, we have learned this in even kinematics. V equal to root 2 gh, right? So what will be its velocity at this point, lowest point, sir? It will be equals to under root 2 into 10 into height it is falling. So this will be 10 root 2 meter per second. This is the velocity with which it is hitting here, right? So if it is hitting this with this particular velocity, what is the kinetic energy? So kinetic energy here is half mv square. And that you can put it as half. Sir, mass we don't know. Let's keep it as m only, right? We don't require it. Let's see how. Okay, and v square, that will be how much? 100 into that will be 200, right? Squaring that particular thing, again you will get 200. So removing this, you will get 100 m. This is our kinetic energy, right? With which it hits the ground. Now when it rebounds, when it comes back, when it rebounds, what happens? Sir, it loses its kinetic energy by 50%. What is the 50% of 100 m? Sir, it is 50 m. So new energy, let's call it as E dash, that is equal to 50 m. Great. So if this is the new energy after losing 50%, what will be the new velocity? So mass still remains same, law of conservation of mass, half mv square. And what is this v? Let's call it as v dash. So taking this m cancels with m, taking this that side, 100 equals to the new velocity v dash square. Taking this, that will be 10 equal to new velocity v dash. If this is the velocity with which it goes up, what will be the maximum height it can reach? So simply put here 10 equals to under root 2gh dash, new height it will achieve while going up, right? And squaring both the sides, it will be 100 equals to 2g, g is 10 and h dash. So let's take it that side, it will be 5 meter, that will be the height it will achieve while going back after rebounding and losing 50% of its original kinetic energy, right? Let's see the next one. Again, an important problem, very important question. Question says a particle is released from height s. Let's say this is height s, okay, from the surface of the earth. Of course, we are calculating it with from the surface of the earth, okay, fine. At a certain height, its kinetic energy, let's say it is the certain height, at this height, its kinetic energy is 3 times. So kinetic energy, let's not put it K, let's put it E, equals to 3 times its potential energy at this point. What is the height from the surface of the earth and the speed of the particle at this instant will be? So we have to find this height. Okay, let's assume from this is x. So what will be this distance? So this distance will be s minus x. We have to calculate this s minus x height, right? Okay, and the velocity at this point. Now we know from law of conservation of energy, the total energy at point A must be equal to the total energy at point B. Clear it is? So let's first write the first condition, energy. What is the total energy at B point? Sir, half m. Velocity at point P must be equal to 3 times the potential energy at that point, at point B. Clear? This is our first condition which is given in the problem. Clear? Great. Let's now use our law of conservation of energy. So law of conservation of energy says the total energy at point A must be equal to the total energy at point B. So what's the total energy at point A? So total energy at point A must be equals to mgs. Clear? Only potential energy. Once it starts falling, that potential energy is converted into kinetic energy, right? So here at point B, it will be the sum of kinetic plus potential. So what is the kinetic here at this point? Sir, it is half mv square. And what is the potential energy now? Be very careful, you will not write mgx. We always calculate it from ground. So this will be mg s minus x. Many students go wrong here. Okay, they take it as mgx. Be very careful, we are calculating the potential energy with respect to ground, no? Otherwise you will take it as 0. Why you are taking it as mgs? Why you are taking this distance from the ground? Otherwise you will take it as 0. Be very careful. Let's divide it from m, and you left it gs is equals to, what about half mv square? Sir, half mv square is 3 times the potential energy. Okay, half mv square is how much? 3 times the potential energy at this point. Now what is the 3 times? Okay, let me just keep it as m, and let me first substitute this. 3 times, what is the potential energy at this point? So 3 times mg, and what about this distance? H s minus x plus mg s minus x. Let's now divide the whole equation with mg. So this will become, s will be equal to 3 times s minus x plus s minus x. Let's call this s minus x as an apple. 3 apples plus 1 apple. How much it is? Sir, 4 apples. So 4s minus x. So this will give you s equals to 4s minus 4x. Let's take this 4x that side. It will be 4x is equals to 3s. And x will be equals to how much? 3s by 4. But did they ask the height from the top? No, sir, from the surface of the earth. So if it is x, what will be this? So this will be s minus 3s by 4. And cross multiplying and solving, 4s minus 3s, sir, s by 4. This will be our this value. So correct answer for this one is s by 4. We have s by 4 for option A, option B, option C. They're also asking find the speed of the particle. Now speed of the particle, let's substitute it over here. Clear? So here it says half mv square is equals to 3 times potential energy. Now what's 3 times potential energy? This one, 3 mg. And what about the velocity, the distance here? Sir, we got already s by 4. S by 4. M cancels with m. Clear? Let's solve it further. V square will be equals to 2 cancels here, 3gs by 2, and V will be equals to under root 3gs whole divided by 2. Clear? Option A is correct. This is without root. This is only the top numerator is root. So this is our correct answer. Whole 3gs whole divided by 2. That's our correct answer, right? I hope you are clear with this concept. Let's see the next one. A mass M is attached to a thin wire and willed in a vertical circle. Vertical circle, okay, fine. The wire is most likely to break when inclined at an angle of 60 degree from, no, it will most likely to break here because maximum tension is here. Then when the mass is at the lowest point, direct problem. Okay, let's see the next question. Great, again a second problem from vertical circular motion and mixed with the inclined one. Let's see, a body initially at rest, so u equals to 0, okay, fine, and sliding along a frictionless track. Okay, this is a frictionless track of height h, fine, as shown in the figure, just completes a vertical circle of diameter AB. So this is diameter AB is capital D here, okay, fine. The height h is equal to how much? Okay, so you have to find this height. First of all, this point, point A, if the velocity achieved by this particle at point A is enough to get it or to complete this whole vertical part, okay, then that velocity at A must be equals to under root 5g r, correct? So from where you got it? Vertical circular motion. If you are giving a particle a velocity of root under 5g r, sir, what's r? R is the circle, vertical circle's radius which it will cover. If this is the velocity you will give this particle, it will completely cover this circle vertically. Clear? Okay, let me come back to the problem. So this velocity at A must be equals to how much? Sir, it must be equal to root 2 gh. We know that because it is falling under the influence of gravity. So that must be equal to 5gr, correct? And what about the radius? So radius, if the diameter AB is d, then this will be d by 2. Let's square both the sides. So 2gh must be equals to under root, oh, root is gone. So 5g d by 2, correct? G cancels with g, and let's find the height. H must be equals to 5d by 4. That's our correct answer. Let's see, 5d by 4. Yes, option D is correct. Now what is the concept behind it? The velocity required at point A to complete any vertical circular motion is equals to root 5gr. That you have to remember, or you should know from vertical circular motion, right? Let's see the next one. Great. What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? Root 5gr just now we have done in the previous problem. Okay, we will not derive it right now here, okay, because that's a derivation. You can directly remember this, okay, or when I will solve a separate lecture on vertical circular motion, if you require it, you can put it in comment, okay, then I can completely explain you the vertical circular motion. There we can derive this expression. Let's see the next one. Okay, a particle with total energy E is moving in a potential energy region Ux. Motion of the particle is restricted to the region when our potential energy is less than E. Okay, less than E, which is option A. Clear it is? This is our correct answer. So potential energy is less than E. Okay. I hope you are getting these lectures. If you have any confusion, any suggestions, you can put it in the comment box. Okay, I'll get the next lecture, or I'll get new lectures, okay, on in Hindi also. So we'll make a separate playlist, that also I'll put the link in the description. Okay, so we'll continue in next lecture.